Dave Kenworthy here. It's the 16th of the 10th, 2021. Today we're looking at Melissa Campbell's website, and we're on page 29, Stonehenge in meters, which is a very interesting idea to state Stonehenge in meters. And she's using the work of Ewan Mackey, and he's using the modern meter, 39.37 inches. And I'm just going to show you what I think the meters being used at Stonehenge are. So if I go down to the bottom of here and just get rid of that. Thom tells us that the diameter of the Aubrey circle is 105 megalithic yards. So we multiply that by 2.72. It's 285.6 feet. Multiply that by 22 over 7. We get 897.6. And there are 2 meters being used at Stonehenge. And when we work them out in feet, one is 39.6 inches, 3.3 feet, and the other is 39.168 inches. It's 32.64, 3.264. So we can see that the megalithic yard in inches divided by 10 produces the meter in feet. Now we can divide these two into this and we get 2 interesting results. 2.272 meters of 3.3 feet, 39.6 inches in 897.6. And 275 units, meters of 3.264 in 897.6. Now, when we multiply that, when we divide that by 12, we get 275. We get 272. So we can see there's been a switch here. We've got 275 meters of that and 272 meters of that, and that's imperial, but we're getting the number of meters in megalithic units of Thom. And when we use the megalithic meter of Thom, we get 275, and they're imperial units because the imperial is base 11. Now we can have any meter we want between these two. That's the top of the scale. That's the bottom of the scale. In the design, Thom's design of Stonehenge, it's absolutely deliberate. There's no doubt about this, and that's what we need to take with us into looking at what's happening in this article of Melissa's. So let's go back to Melissa's article. And Mac is telling us that in the station stone rectangle there are 104 megalithic yards, which is also the Aubrey hole diameter. And I'm sorry, but that's that's wrong, because I mean, when I say it's wrong, it's in inverted commas wrong, because these megalithic measures, they're so flexible that there's always an argument for a unit. But Thom definitely says that the Aubrey hole diameter is 105 megalithic yards, which is what I've just shown you. It's 285.6 feet. But what we can say is that there are 260 units in the station stone rectangle diagonal, And that is complicated because the assumption is that the diameter of the Aubrey holes and the diagonal of the station stone rectangle are the same, but they're not. And this whole idea that Mackie has produced is right. And it's using this number 260, and we find that Thom uses that in his analysis of Avebury. Turns up a lot, 260. And the reason why it turns up a lot is because it's used as a diameter. And as a diameter, it's a count of the eclipse danger period. And now I'm going to show you how it's working at Stonehenge. And it's so complicated, it's fall off your chair complicated. And I've called it defudging Mackie. Now, I'm not criticising Mackie because he's done this very sincerely and genuinely. And sometimes when you write these things down, people read it and they think, oh, he's just having a right go at Mackie. He's got no right to do that. But I'm not. Because the whole idea of what Mackie's done is spot on. He's just used that for the diameter when Thom's used that. But when we use the station stone rectangle, we find that the diameter of the Aubrey has changed to 286. And the explanation for why is because we have to use Thom pi, 40.8 over 13. And we get the perimeter is 897.6. And that's the reason. When we use 285.6, we get that. This is a pi calculation device. So you can have any version of pi you want between these two by just changing the diameter. And this is what I'm saying. And Melissa says, so can we go with a station stone rectangle that measures 80 by 33.3 metres, as Jim Allison pointed out on GHMB? Yes. Because 286 divided by 3.3 is 86.666 metres. And that makes the 12 side of the 5, 12, 13 triangle, Pythagorean triangle, 264. And that's 80 metres. And then the short side is 110, which is 33.333. And when we use a Drusian foot or the Indus Valley foot, what we find is they're 100 because it's 1.1 feet. And 3 of them make a metre. So we've got 100, 240 and 260. Divide that by 2. We've got the 5, 12, 13 triangle, the Robin Heath triangle. Now we can look at what I've found at Stonehenge. And it's this. This 5, 12, 13 triangle I found when I first started to examine the relationship between Stonehenge and Avebury. I drew this line up to Avebury, and it's on a back bearing of 176 degrees exactly. And when it's 17.333 miles, which is a tenth of an eclipse danger period, 17.333 units, it hits Thom's 345 triangle in the centre of the Avebury site. So 17.333 miles on a back bearing of 176 degrees is hitting Thom's work at Avebury. And we find that we can draw a right-angled line down the Stonehenge cursus, and it's 7 units of 1320 feet. The lesser cursus is 1320 feet, representing 1 unit. And when we do that, we can find this, what I call the megalithic cross. And each side is based on the imperial mile. So that line there is 5280 feet. This is a 345 triangle. And look at the units, 3960, that's a metre. So they were using the metre in this diagram. And we can find the megalithic yard by adding that to this. And we find that there are 15 Aubrey circles in this distance. So it's 15 times 330 megalithic yards, this length. You know, it's an amazing result. And what we find is this lunation triangle I've drawn here is 36 times scaled up against the lunation triangle in the Aubrey circle. It's 30. The unit in the Aubrey circle that's being used is 22 feet. And go back to it. So it's 286. And we divide it by 22. We get 13. And we can see we'll get 5 when we divide 22 into 110. So all I'm saying is everything in Mackie's article is right except the unit that he's using. And we can use two versions of the meter. Melissa asked the question and I say, yes we can, Melissa. The meter's 39.6 inches. But we've also got this other meter, 39.168. And when we multiply the two together, we get 10.7712. And when we work out the Aubrey circle in inches, we get 1077.1.2. So we can see the 2 meters are working together there. And we can take any meter we want between these two at the Aubrey circle and adjust pi accordingly. It's very, very complicated. And this is, I mean, I've covered this in my presentations, but there are 2 versions of pi being used. When we've got 286 as the station's stone diameter, we've got pi as 40.8 divided by 13, giving 897.6. And when we've got 105 megalithic yards, giving 285.6, we use 22/7 for the same result. No change. The perimeter is always going to be 897.6, but the diameter is going to fluctuate between these 2 values depending on the version of pi that's being used. And this is exactly what I've been saying for a very, very long time. The Aubrey circle is a pi calculation device. And you can choose any version of pi you want between that and that. And I've demonstrated beyond any reasonable doubt that these 2 versions of pi, 40.8/13 and 22/7, when multiplied together they give 897.6. And when we use this version of pi that's really close to real pi, 3.1416, we subtract that from that, we get that. And we divide that into that, we get 1,000, and that into that, we get 1,001. We do the same for this, and we get 2,500 units in that, 2,499 in that. All very deliberate, giving pi squared at the Aubrey circle, which is covered in my presentation, where we've got pi cubed being used. We've got this version of pi squared being used. Melissa's also going with this version of, with this unit. She's saying, is it somehow relevant, this unit? And yes, it's the Thom cubit at Giza. Multiply it by 1200, that's the Earth's circumference. Multiply it by 1760, that's the Giza base. Now this version of the Earth's circumference has to be used with Thom pi. So we go plus that divided by, and we go looking for Thom pi. And it's there. 787878. So you can see that there's a reason for that. And if we go into miles, so we multiply that, we get that unit there. And if we divide that by the same version of pi, you can see we're getting a solid unit. You know, there's no decimal points. It's just a perfect unit using Thom's pi against that version of the great circle there. So everything's stacking up using this unit. It works as Thom's cubit. And also if we take if we take 99% of it, we get 20.4, and that unit will work at the Aubrey. So we multiply the Aubrey and divide by 20.4. We get 528. You know, I mean, what can I say? These things always resolve to either the imperial system or Thom's system, because they're working together at the Aubrey circle, and they're also working with base 100. And Thom's megalithic rod is 100 megalithic inches, and the equivalent unit in the imperial system is 66 feet, which is a cricket pitch. It's a chain, and it's 100 links. It's the same system, exactly the same system that Thom's discovered. It's just that it's scaled up by 34 divided by 33, and that's it for this. It's very complicated. It's very difficult to put across. But what I want to show Melissa is that we can use Thom's work to get the right result. And that's it for now. Thank you.